Hello all. Today we'll be seeing about superconductivity and the theory that explains it, that is the BCS theory. So, according to BCS theory, superconductivity is a microscopic effect. And this BCS theory is a quantum mechanical theory or the first microscopic theory. So, this theory was proposed by three scientists, Bardini, Cooper, and Sheriffer. These three are the scientists who proposed it. And here you can see that a superconducting material is levitating over a magnet. So when you say superconductivity or levitation, to give a better example, let's think about the maglev vehicles. Over there you can see that the vehicle is completely levitating above the ground or floating over the ground, and that's due to the repulsion of all the magnetic field lines away from it, and it causes the vehicle to levitate over the ground. So this action is explained with the help of BCS theory. So BCS stands for Bardini, Cooper, and Sheriffer as we know it. The BCS theory explains the superconductivity only for type 1 superconductors, and it does not hold good for the type 2 superconductors. That is because the type 1 superconductors obey the Meson effect completely, and the type 2 superconductors do not obey the Meson effect completely. And as you can see here, that the three scientists had also won a Nobel Prize in Physics for this theory in 1972. And the BCS theory was proposed in the year 1957. So let's go on with it and see about Cooper pair formations. So Cooper pair are formed with the interaction between electrons and phonons. So Cooper pair is a pair of electrons that have opposite spin. And this phonon is a quanta of vibration energy. This is the phonon or the vibration energy that is present in a metal lattice. Going further with it, over here you can see that it's said, or we also know that electrons do not attract each other because of the negative charges or the repulsive effect of the Coulomb forces. But in the Cooper pair formation, they attract each other or they come together and they form the Cooper pairs. The idea of superconductivity began intrinsic to the structure, was led by several discoveries to do with the property of superconductors. So the BCS theory of superconductivity. So here you can see that it said it is a quantum mechanical theory to explain superconductivity. According to this theory, superconductivity is due to the formation of Cooper pairs. So this Cooper pair is the main reason how we can explain the superconducting effect. So Cooper pairs are the pair of electrons formed by the interaction between electrons with opposite spin and momentum in the phonon field. So this is the phonon field that we are seeing, and when you have the electrons moving through them, you can see that the phonons are actually displacing from their lattice and getting attracted towards the electrons. So let's see further about it. The flow of current in a superconductor causes attraction between the electrons and positive ions. You can see it over here also. So when the electrons are flowing through the superconductor, you can see that the phonons or the positive ions are getting attracted towards it. And due to this, the positive ions get displaced from its position, as I said before. When a second electron reaches this distorted position, it also experiences attractive force. So when the first electron passes through this, it pulls the positive ions closer to it. And when the second electron also comes towards it, that also experiences a attractive force because of these positive ions. And thus we have attraction between two electrons taking place via the lattice. And that means you can see that when these positive ions are coming closer, that the first electron is also present over here only, and it's getting attracted to this positive ions. And the second electron also enters the same lattice. This electron is also attracted by them, and they get uh, a pair formed over there, as you can see over here. So this is the Cooper pair formed over here. between the electrons. Let's see further about it. Hmm. This pair of electrons form Cooper pairs, as I said right now, and in the given superconductor, each Cooper pair causes the formation of many number of such pairs, uh, causing the formation of cloud of Cooper pairs. So when a Cooper pair is formed, they also affect the lattice more, and that helps the formation of many number of Cooper pairs, or you can call it like a chain effect, where the moment you have one Cooper pair formed, that increases the number of Cooper pair formation over there. And when the temperatures exceed Tc, or the critical temperature, it is only when this critical temperature is maintained, the superconductivity effect is seen in the materials or the or the conductors. And that's because when the temperatures are lowered, you can see the formation of Cooper pairs over there. But when the temperatures increase than the critical temperature, the Cooper pairs are not formed because the electrons are not having sufficient energy further to maintain their Cooper pair formations. So that is what is explained over here. And this is the maglev vehicle that I was speaking about, which is an effect of superconductivity. So thank you. That's all for now. And I guess I have explained about the BCS theory and how it explains superconductivity. Thank you.